Okay, under graphs, functions of the form of y equals to mx type of graph. That's why we are going to discuss here. That is really simple. You know what is meant by y and x. X means respective x coordinate. X axis would be the horizontal axis. In this, you will have x coordinates. Y axis, that is our vertical axis. But here, a new thing appeared here. No? Y equals to mx. What is meant by this m? So actually, we can classify the graphs into several types. So this is the basic type of classification of to draw a linear graph. Linear graph means straight line graph. This is a straight line graph, straight line graph, straight line graph. These kind of graphs are called as linear graphs. Another similar name to specifically indicate a particular straight line graph, we are using the term called functions. Okay, functions of y, functions of x. So instead of, so we are using to, this is, there are several graphs. No, this particular one would be a function. Next one, this is a function, this is a linear function. By using its formula, we can specifically indicate particular function. I will explain that one while we draw the graph, so no need to worry about it. Now let's come to the m thing. Okay, what is meant by this m? So this is, actually think about it. You are having something 2x equals to 4. The number situated before the x quantity, this is called as coefficient. Okay, coefficient. We are familiar with this term coefficient already. So here also this x value is having a coefficient. In linear graphs, this m is called as gradient, gradient or slope. In some books, you can refer gradient. In some, you can encounter the wording called slope. This is showing the inclination of graph. Okay, when we draw the graph, you will understand what is meant by the inclination. X is a known one. X is x coordinate, y is y coordinate. According to question, this m is changing. Sometimes m can be 1, 2, half, -1, -10, -100, -99, -0.5, +1.5, 2.2. Likewise, m can have any values. Okay, any value. So in those cases, you will have a proper understanding about this gradient and slope thing. This is showing the inclination of our function. Inclination of our function. Do not worry about these terminologies. When we draw at least one graph, you will be familiar with these terminologies. Gradient or slope, inclination, function, there are several terms. Okay, drawing a graph means which is included with both axis and the straight linear graph, altogether called as graph, only to specifically indicate this straight linear function. We know x and y axis already, know. To indicate this particular plotted coordinates connection will give you a particular graph like this. This is specifically indicated as function. Altogether axis, that is called as graph, only to specifically indicate that particular linear function, sorry, linear scale, that is called as function. So that is the difference between graph and function. So if I talk about graph, I'm talking about the whole thing, axis and coordinates and the straight linear graph, everything. Function means only the linear thing. So as I mentioned, m can have any value. So for an example, here I will take m as 2, y equals to 2x. This is our graph equation. By using this graph equation, first you should produce coordinate table. First thing is coordinate table. Okay, let's start to draw the coordinate table. So that is not a big discussion, big thing. Okay, that is really simple. In the question, no need to worry. X values will be offered by the exam paper. In the exam paper, definitely they will give you the X values. Negative 2, negative 1, 0, 1, 2. Okay. These are the given X values. Mostly this is consist of some negative values, zeros and some positive values. Altogether they will give you X values. But as ourselves, we need to find its respective Y value. Okay, respective Y values. These are single values, no? Each are having single values. So this is called as discrete variables. Discrete variables. Discrete variable means X will have not only a single value. By using a single value, we cannot plot our function, no? Actually, we at least need 3 or 4 or 5 points to connect them to produce a straight linear graph. That's why we need several points to connect them to produce a function. So all these individual values are called as discrete variables. Discrete variable means all are having different values. Different values. That is meant by discrete variables. Now let's come to the uh, coordinate table thing. X values, these are discrete variables. X will have several individual different values. Several individual different values. That is called as discrete variables. Y? Okay, how can we find the Y? That's why you have to use this graph equation. Y is equals to 2x. We already know the x value. This is a substitution thing. So we know y is equals to 2x. 2x, no, that is the given formula. So I will write 2x here. Y should be 2x. In this particular occasion, x is holding the value of negative 2. So 2 multiplied with negative 2, that will give you the y value as negative 4. When the x is negative 2, y value would be negative 4. Y value would be negative 4. Now let's do the same thing for the next discrete variable. 2x. Here also y is equals to 2x. 2 times of, in this occasion, x value is negative 1. So instead of x, you should substitute negative 1. It will give you 2 times of negative 1, negative 2. Same thing here as well. 2x, 2 times of 0, that will give you y as 0. Then 2 times of 1, it will give you 2x. Sorry, 2x, 2 multiplied with 1, that will give you 2. Then finally also 2x. 2 times in this particular occasion x value is 2. 2 times 2, it is 4. Okay. Almost 90% of our work done with this. Thereafter, writing the coordinates. Most of the students forgot to do these things, but definitely you should have an identification about to indicate your coordinates. I will mark. So when x is negative 2, we found y value. So we will write that one as a coordinate here. Okay. Below this table, you can identify the coordinate. When x is negative 2, y is negative 4. This is one of the coordinate in our function. Next one, when x is negative 1, y value is negative 2. You know how to indicate the coordinates. First, inside the bracket, by using commas, you should indicate x value and y value in order. Then 0, 0. That is the third coordinate. Fourth coordinate when x is 1, y is 2. Final coordinate when x is 2, y is 4. This is the coordinate writing. Coordinate. So hereafter, the planning. Two left first. The graph equations and x values will be offered by the exam paper or by me. Thereafter, by using coordinate table and some calculation, you have to identify y coordinates respective y value. Thereafter, coordinate formation. Then planning of the graph. Sometimes you might saw that this is your graph axis. They will draw the graph somewhere here. Okay, somewhere here. I will draw two graphs and take a look. This is a graph. Okay, this is a function and this is another function. Amongst these, which one looks better? That's obvious. The second one is looks perfect because here this is this looks compacted one. Here the planning. There is a small error in your planning. Think about it. Your house. Okay, there are some fence walls here. You should just make a small gate here. So while that planning, if you made a small 1 centimeter error, okay, 1 centimeter error here, you cannot close the gate fully, or else if one is 1 centimeter less, the gate is still open after closing also. That is not perfect. No, you have to have a compact, perfect measured gate for your house. Same thing here as well. The planning it's okay, but while doing the execution or in the latest part of the planning, they made a mistake. That's why the graph looks really small comparative to the axis. But here look at this, both axis and graphs, this looks good. So this is the thing we have to compete while dealing with the planning thing. Okay, I use the gate example for some explanation only. Now think about it. In x-axis, what are the values needed? In x-axis, what is the minimum value we need in our x-axis? The minimum value is -2. What is the maximum value needed in our x-axis? That is +2. -2, -1, 0, 1, 2. So, you can keep your graph limit in x -2 to +2. That is totally enough. Next one, y. In y coordinates, what is the minimum value? -4. Maximum value is 4. Accordingly, we have to plan our axis. This is the planning part. Planning part. Now, let's come to the execution part. The last one here. In the execution, what we are going to do, we just plan, okay, in the compact graph, we need in x is -2 to +2, in y -4 to +4. Accordingly, let's make our graph. I will mark here -2 with same distance, -1, the gap should be same. Here it is 0, 1 and 2. This is my x-axis. Now I'll produce my y-axis. So here, the minimum value is -4. So I will use the same gap as x-axis. -1, -2, this is -3 and -4. Even though there are some spaces, we don't want that. Just leave it. And here, +1, +2, +3 and +4. This is my y-axis. I have to check whether all the things are included here. All the x values okay and y values are okay and 0 also indicated. The labeling of x is also, most of the students forgot to do that thing. That is really important. This is our x-axis, the horizontal one, vertical one would be our y-axis. Okay. Now we came to the last part of this graph formation here. To plot the coordinates on the Cartesian coordinate plane. We have 5 coordinates. You have to plot them in your Cartesian coordinate plane. What is our first coordinate? -2 and -4. -2 and -4. So this would be the location of your Cartesian coordinate, first coordinate. After making this dot, to ensure that dot, sometimes in your Cartesian coordinate plane, if that is too vast or too long, you cannot identify the points. To ensure to identify that, you should make a dot. Thereafter, surroundingly, just draw a small circle. Small circle. So that will identify you, okay, we have a coordinate here. Same thing you should follow in other coordinates as well. Then let's mark our next coordinate. X is -1, y is -2. X is -1, Y is -2. Okay. Mark the coordinate to ensure that draw a circle. And third coordinate 0, 0, 0, 0. Here, this is the location. Just draw a small round. And fourth coordinates 1, 2 through x-axis 1, y-axis 2. Okay, just draw a small circle. And last thing is the coordinate 2, 4. 2, 4. Here, and encircle it. After plotting your coordinates, once more check whether this is in an alignment. Now you can obviously see, okay, so when you connect all these points, you can easily produce a straight line. That is why we are drawing this. That's why we are drawing this Cartesian coordinate plane and coordinates to connect to produce a function here. That is our ultimate goal. No? Okay. Then by connecting all these points by using your ruler, you can produce a straight linear graph. You can see this line is going through all the coordinates -2, -4, -1, -2, 0, 0, 1, 2, 2, 4. Finally, just name this graph. This graph is having, sorry, this function means I am only talking about this one, not the planes, not the axis, not the points. Only I am talking about this linear graph. So this function, the naming, that is also playing a crucial role here. So in sometimes in the same Cartesian plane, you should draw several graphs, several functions. So to identify them in the bottom or in the top, you can name it. So I will write the name of this graph here. This is y equals to 2x. Y equals to 2x. This would be our graph and function formation. After drawing, just on either of this end, you can mark y equals to 2x. No need to mark the graph name in both places. At once, at one place, that is totally enough. And yes, that's all. That's all about y equals to 2x graph. Let's have a quick recap. What we did first, the graph equation and respective x coordinates were given. By using the graph formula, we just did the substitution part to find respective y coordinates to complete this coordinate table. Thereafter, write the coordinates within the graph, within the bracket. Then planning part in x-axis, what is the minimum and maximum values were needed to plot our function. In y-axis, what is the minimum and maximum value? Accordingly, plan your axis. -2 to +2, -4 to +4. Then carefully just mark your coordinates on the Cartesian coordinate plane to ensure whether that is correct or not. After marking, just draw a circle to ensure there is a point here. Then by using a straight line ruler, you can produce the straight linear function. Finally, just name it. Just name it. And one more thing, don't limit your graph from here to here. If you have 5 points like this, not only connect only these 5 points, okay? Just you should keep a small distance after here and after here as well. Just extend this a little beyond the coordinates. Beyond the coordinates, just extend this one a little. Don't just limit your graph from here to here. Okay, so just extend a little for our further purposes. We will discuss them in our next example.